Hello everyone, I'm Matt Kazani from Stroud Research Center. Today I will go through the process of carrying out a quality control check of your sensor station. Sensor station quality control should occur on a quarterly basis or every 3 months within the year to monitor the quality of the data as well as to provide reassurance of data quality to those who will be using the sensor station data in analysis. The quality control process cross-checks the sensor station's depth readings, water temperature readings, conductivity readings, and turbidity readings with handheld meters and basic tools. Before heading to the site of the sensor station, you should bring the following to complete your data quality control task: a field visit data sheet to record sensor and handheld meter readings, a sensor cleaning brush with soft bristles, a watch or cell phone to record time of cleaning and data readings, a phone or camera to take pictures of the site or sensors if necessary, a conductivity meter and its calibration solution, a thermometer, a plastic ruler that reads metric units for water depth cross-checking, a turbidity meter and its calibration solutions, a microSD card to switch out with the one installed in the logger box, and a microSD adapter or microSD case to protect the data card during transport. As a reminder, the handheld meters pictured in this video are one of many options for performing QC of the sensor station data and should not be considered the only choice. Prices of a handheld meter will depend on the type of purchase and depend on which vendor it was purchased from. Prices for calibration standards have a similar dependency on type and vendor. Some protocols for calibration and setup can differ between meters as well. Before using any handheld meters in the field, be sure to follow their instructions to properly calibrate. This can be done at home or at your vehicle before traveling to the station. All handhelds should be calibrated at the beginning of every quarterly QC visit to provide data users and the station manager evidence of reasonable accuracy of the quality control process and to track the drift of the handheld itself. Each quality control device requires different steps and calibration standards to properly calibrate it before usage. Be sure to closely follow the instructions and other information materials provided with the device. Be sure to record the name of the meter and the calibration result of each instrument onto the field visit data sheet under the Quality Control Chemistry Field Meter Information section. In Stroud's Quality Control Kit, we use a HANA conductivity meter with a range from 0 to 2000 microsiemens per centimeter. This meter is calibrated with a packet of solution that has a known conductivity of 1413 microsiemens per centimeter. We turn on the conductivity meter first. Carefully tear open the calibration packet to prevent spillage. Hit the calibration button on the conductivity meter and lower the sensor ends into the packet. This conductivity meter will automatically calibrate and notify us when the calibration process has been completed. This result is then recorded under the Quality Control Chemistry Field Meter Information section. We then seal the used calibration packet into a Ziploc or pour the fluid into a jar and toss the empty packet into a trash bag. For performing quality control and turbidity, an in-house created turbidity probe connected to a digital screen is used to show values in real time. This handheld does not need any field calibration since the probe was factory calibrated with a few turbidity calibration standards and is guaranteed by the manufacturer to last for years. There are a variety of instruments that can be purchased to cross-check turbidity data. Prices can range from less than $100 to hundreds of dollars. Some are simple construction, while others are digital meters. Some require calibration with multiple standards, while others use your sense of sight to gauge the turbidity value. The process used to measure turbidity will vary between instruments. For performing quality control and water temperature, Stroud uses a Durac waterproof electronic thermometer. This instrument is factory calibrated. It only needs recalibration every 6 months or so. The suggested process for this specific instrument is the freezing point method. For performing quality control in the water depth, Stroud uses a simple ruler rather than an electronic instrument. No calibration is required for this tool. Do take note of where 0 is marked on the ruler since that designates where the front of the ruler is placed when QCing water depth. If there are other probes attached to the sensor station besides turbidity, conductivity, depth, and temperature, you should consider purchasing instruments to QC those as well for a full data quality check. Just as a reminder, be sure to record the name of the meter and the calibration result of each instrument onto the field visit data sheet under the Quality Control Chemistry Field Information section. Once on site of the station, begin filling in the metadata section of the field visit data sheet with as much information as possible. Before starting the quality control process, use the sensor cleaning brush to properly clean the sensor probes in preparation for data point comparison. Be sure to record the exact time when the cleaning occurred. There is a separate video regarding the proper way to clean the CTD and turbidity sensors. Please refer to that separate video if you have any questions regarding this step. Begin the process by performing quality control on water depth. Record the staff gauge's water level in the quality control water level data section of the field visit datasheet. Take note of the time when the staff gauge was inspected for water depth. Remember when reading the staff gauge that the number shown on it is in centimeters, so divide by 100 to convert to meters. And the bottom of the black tick indicates a whole number, while the top of a black tick means the water is resting at the halfway point. Then, feel around the CTD probe for the window where the water depth disc is located. Take the plastic QC ruler and line up its edge next to the edge of the opening. If the ruler you're using has a gap between the edge and zero, line it up with the bottom edge of the CTD slot. If the ruler has its zero directly at the edge, line it up with the top edge of the CTD slot. Take note of the water depth measured by the QC ruler. This will be recorded on the line labeled QC Sensor Station Water Depth. Record the time when the QC ruler was used to measure water depth. Use the recorded staff gauge time and QC ruler time to find the correct sensor station time and depth. Look through the data on the SD card for the date and time of the process. Once the correct date and time are found, record the sensor depth data point found on the same line. Remember, the SD card only reads data in Eastern Standard Time, or EST. Most of the year is in Eastern Daylight Time, or EDT, depending on the month. Convert from EDT to EST by subtracting an hour from EDT to correctly match up your staff gauge time and QC ruler time to the sensor time. To calculate the correct offset, follow the equation provided on the field visit datasheet. This equation requires the staff gauge value and the sensor value found on the SD card. Flipping the field visit datasheet to the back, you'll see the next parameter to undergo QC is conductivity. Take your already calibrated conductivity meter and follow its instructions on usage. For Stroud's HANA conductivity meter, remove the black cover and hold the instrument an inch or two in the water. An hourglass icon will show up on the screen indicating that it is taking a reading. The hourglass will disappear and the conductivity value will stabilize for a few seconds to notify the completion of the meter's reading process. Be sure to record the conductivity value and the time the value was produced in the Quality Control Chemistry Data section of the Field Visit Datasheet. Below conductivity is water temperature. Remove the protective white sleeve from the calibrated thermometer. Turn the instrument on via a button. Lower the metal probe into the water and wait for the value on the screen to stabilize. You can press the hold function to keep stabilized value on the screen even if you move the instrument around or take it out of the water. Be sure to record the time when the value was stabilized. Next is turbidity. There are a variety of instruments that can QC this parameter. You will take the calibrated instrument and dip the probe attachment into the stream, or you will take a small sample and attach it to the calibrated instrument to read. In Stroud's case, we use an in-house built instrument that attaches a Campbell Scientific Turbidity Probe to a mayfly board. The instrument is turned on by pressing a button. We then lower the probe into the water a few inches. We avoid getting too close to the stream bed and have the probe window facing away from the user. After a few seconds, the screen will show the value stabilizing within a small range. Sometimes a single value will stay on the screen. Usually, the median of the range is considered the instrument's value. The measured result and time it was taken is then recorded on the turbidity parameter row of the Quality Control Chemistry Data section of the Field Visit Datasheet. There is space on the Field Visit Datasheet to QC a dissolved oxygen probe if the sensor station contains one. There is also blank space in the Other in situ parameters section to record QC values for additional parameters that your sensor station is measuring besides the mentioned ones in this video. Once done recording the results and times for each QC instrument, be sure to collect the SD card from the sensor station. This is an important step for the whole QC process. This allows the values produced by the QC instruments in the field to be connected to the sensor measured values at the same time. You do this by noting the QC time and finding the EST equivalent on the SD card. Remember that the sensor data will always be in standard time, but you will sometimes be QCing during daylight savings time. There is a separate video that walks through the process of extracting the SD card and replacing it with a blank SD card. as well as correctly searching through the sensor data on the SD card to match your QC instrument value to the sensor value. This concludes the process on how to perform quality control or QC on the sensor station. At a minimum, this should be done quarterly or every 3 months. Remember to completely fill out the quality control sections of the field visit datasheet. This means recording all timestamps when QC was performed for a certain parameter and recording the sensor values that match with the timestamps. The QC instruments used in the sensor station sensors may not have the same value, but should produce values fairly close to each other. The process of QCing is more about monitoring sensor value drift and relative accuracy, rather than looking for direct matches between the field instruments and the sensors. Thank you for watching. I'm Matt Kazani from Stroud Research Center.